This is a presentation on the Decorator design pattern by Wendy Maxwell and Ashley Murray for CS364 Software Engineering 1. So, what is the Decorator design pattern? It is used to, quote, add responsibilities to individual objects, not to an entire class, close quote. This can add one, two, or many traits from a list of responsibilities or traits to an object, quote, dynamically and transparently, close quote. In other words, the responsibilities are added at runtime without affecting other objects. This is a more flexible approach than subclassing. A decorator is also known as a wrapper, which makes sense when you think of it as, quote, a skin over an object that changes its behavior, close quote. When using the decorator design, you start with a very simple class and have other small classes that you use to decorate your base class. It is analogous to having an interface that is a cupcake. You then create a basic cupcake class and a decorator class that each implement cupcake. You can then have frosting decorator, sprinkles decorator, and candle decorator classes that can be added to the basic cupcake, but you can add only the classes that you want. The cupcake in this picture has been wrapped in a frosting decorator and a sprinkles decorator, but not a candle decorator. If it was a cupcake for a child's birthday, it might have a frosting decorator, a sprinkles decorator, a candle decorator, and an edible superhero figure decorator, because you can add more wrappers as the need arises. If it was a plain, unfrosted cupcake, we could argue about whether to call it a cupcake or a muffin, but it would still work because decorator classes are optional.
Let's work through an example. In this example, we'll be creating a decorator that allows us to add additional information for each book. Using the decorator allows us, or the user, to select the pieces of information they want for each book. In this example, we will be hard-coding the information, but if implemented, we would allow the user to select which information is needed and would gather it from the user's input. This is an example of a UML diagram for the decorator design pattern. We will be using it as a template to create our code. The first thing we need is to create an interface. When creating the interface, we need to understand which methods are needed. These methods will be required for all other classes underneath it, including the decorator. For this example, we will only be implementing a getDescription method. Secondly, we will create a concrete class. This will be our most basic form of the book info. Because we require that every book have a title and author's first and last name, this is what we will include within this class. Here's our code example. As we can see, we have implemented the book interface, which allows us to include the getDescription. We are creating our base book, or our core functionality. We've created for the getDescription method the ability to add the author info and the title, which will allow the description to return this. The next thing to do is create a class that will be your decorator class. For this example, we have called it a decorator, but that is not required. This will include all the optional additions to the base book or core functionality. Within the decorator class, we have implemented book as shown by the orange box. This allows the rest of the decorator classes to have the same access to the getDescription method and also the ability to get the base book info. If we had other methods within our base class, this would also have access to those. Now comes the fun part. We now have the option to include as many additional types of info for the book as we want. Including a new one is easy to set up and allows you not to have to touch old code old code other than a few adjustments. Here in our example, we've implemented a new book description. As you can see, extending the descriptor decorator allows the class to have access to the base book and interface and allows us to add things to the get description. Also note that we call the book by implementing the super keyword. This is normally used inside a subclass method, like this one, to call a method defined in the superclass, or for example, the descriptor decorator. A second option we added was the book genre. Here's an example of that code. Again, note the super keyword and the additions to the get description. Lastly, we will have main call each of these decorator classes and have them added to the base book. Here you can see that we have implemented all three: the base book, the book description, and the book genre. Running the program, you can see that each of the methods were called, adding the genre, author and title, and the book description. This all allows for the system to print all the information we need. With the decorator, we are able to add more information or call specific pieces of info for each book.
There are many advantages of using the decorator design pattern. Responsibilities are added to objects at runtime, not when the code is compiled. There can be any number of decorators, so more can be added if the need arises. The order of the decorators doesn't matter. The functionality of an object can be extended without affecting any other objects. It has more flexibility than static inheritance, and it allows for a simple and precise base class. There are some disadvantages of using the decorator design pattern. All methods in the decorator interface must be implemented in the decorator class. You can end up with many small objects, some might say too many, and it could be complicated to have many layers of decorators. We strongly recommend that the decorator design be used to design our book stash app. We have a fairly simple base class, a book, that could have a wide variety of decorators like genre, description, date published, etc. This design pattern would work very well for what we are trying to accomplish. This is a list of the sources we used in the creation of this presentation. We hope you have learned a few things about the decorator design pattern. We definitely have. Thank you for watching.